Hi everyone, welcome back to chemistry. In this video, we're going to talk about our final reaction type, which is oxidation reduction reactions, or redox reactions for short. So redox reactions are actually responsible for lots of different things that we see in nature, one of which is the phenomena of iron rusting, which you can see on the right there. So what is an oxidation reduction or redox reaction? So in a redox reaction, electrons are actually transferred from one substance to another. And we call that transfer of electrons either oxidation, which is the loss of electrons, or reduction, which is the gain of electrons. And you always have both in a redox reaction, right? If one thing loses electrons, another thing has to gain them. They don't just disappear, right? So we like to identify in chemistry which substances are being oxidized or losing electrons, and which substances are being reduced or gaining electrons. So let's look at this example here. We've got two substances, A and B, on the left, and A is actually losing its electron to B. So we see that curved arrow there. That means the transfer of electrons. So going from A to B. So A is kind of giving its electron away to B. And then you can see here, B has gained that electron on the right there. Okay, so when we lose electrons, that's called oxidation. And we can say that A, the thing that lost electrons, was oxidized. Here it's just one lonely electron, but it can be more than one, and it will be sometimes. So you'll get really used to these curved arrows if you go on to take organic chemistry, and you'll learn a little bit more about how they work in the future. But just so you know, that's what that means. Okay, so A lost its electron, so it was oxidized, and B gained that electron, so it was reduced. So whenever you have one thing being oxidized, you have to have another thing being reduced. If one thing loses electrons, another thing has to gain those electrons. And we call the thing that gained electrons, we say that that was reduced. Or we call that phenomena reduction, gaining electrons. And there's a way to actually memorize a little bit easier which one's oxidation and which one's reduction. And there's actually a mnemonic that you can use to memorize this a little bit easier, and that's called oil rig. So you can memorize that oxidation is lost, that's the oil part of oil rig, and reduction is gain. So that's the rig part of oil rig. So oxidation is lost and reduction is gain. Another mnemonic that I've heard before is Leo goes gur, but I'm just going to write Leo gur here, like a lion gur. And it's the same idea. Loss of electrons is oxidation, gain of electrons is reduction. So whichever one helps you kind of memorize this, whichever one kind of sticks out in your brain, that's the one I'd recommend using. So whatever helps you the most. Okay, so a kind of like real world example of a redox reaction is, you can see here on the right, we've got the Statue of Liberty. The statue wasn't always green like that. The reason that the statue is green now is because the copper metal has been oxidized, and as it oxidizes, it forms a kind of green solid called copper 2 oxide. How did I know it was copper 2? Well, we have copper 2 plus here. And I also read it in your book. Okay, so that green stuff that we see on, that green solid that we see on the Statue of Liberty is also called patina. And yeah, it's due to a redox reaction. So let's take a look at that redox reaction that happens. The way that your book likes to explain this, explain redox reactions in general, is by breaking them up into half reactions. So that's what these two things are. These are half reactions. And this is the full reaction right here. Okay, so what they've done is they've split this reaction up into two separate parts where we can see what's being oxidized and what's being reduced. So for the first half reaction, we have copper with no charge, right? Just copper in its regular elemental state, just copper atoms. And we have 2 of those copper atoms. And after the reaction, it's been oxidized. So what does that mean? Well, remember, oxidation is loss. So that's loss of electron. It's lost 4 electrons, and it's become copper 2 plus. Why is it lost 4 electrons, but it's only copper 2 plus? Yeah, we have 2 of them, right? We have 2 copper 2 pluses, and each of those coppers have lost 2 electrons. Okay? All right, so that copper has been oxidized. So something must have been reduced. So yeah, oxygen was reduced. So oxygen had no charge, and it gained those 4 electrons that copper lost, and now it has a 2 minus charge. It's gained those 2 electrons, or sorry, those 2 electrons each, but we have 2 oxygens. So it's been reduced, right? And if we look at just these numbers here, these are actually called oxidation numbers. And what are oxidation numbers? Right now, you could just think of them as the charges on, they basically are. They're just the charges on these atoms. So in the beginning of this first half reaction, we have a 0 oxidation number, or no charge, on copper. And then after it loses those electrons, each copper atom or ion has a 2 plus charge. So it's gone from a 0 charge to a positive charge. Okay, and that's oxidation. It's lost electrons to get more positive, right? Just like when we talked about, our positive ions like lithium, sodium, magnesium, our metals, those are losing electrons, but their charge is getting positive. Why? Well, electrons are negative, right? So they're getting more and more positive, those atoms. Okay, so that's oxidation. What about reduction? So we can also use our oxidation numbers to understand which thing was reduced. So oxygen was reduced because, let's look at these oxidation numbers. We go from 0 to 2 minus. We go from neutral, 0 charge, to a 2 minus charge. So what does that mean? Yeah, we gained negative charges. Yeah, so that one was reduced. We gained negative charges. We were reduced. So your book likes to split all of these redox reactions into half reactions, but you actually don't have to do that in order to see what thing was oxidized and what thing was reduced. So let's practice that real quick. This is the same chemical equation, but I wanted to show you how we could figure out what's reduced and what's oxidized without actually splitting it up into half reactions. So what you're going to want to do is you're going to want to assign your oxidation numbers, assign your charges to each of your atoms. What do I mean by that? So what is the charge on this copper right now? Yeah, it's neutral. It's neutral. Why? It's not bonded to anything. It's just copper by itself in its elemental form. Okay, it's as a solid. It's not aqueous. It's not like dissolved in water or anything. So yeah, it's just copper on its own. So we're gonna say that oxidation number for copper, or the charge on that copper, is 0. Okay. What about this oxygen, O2? What's the charge on O2 right there? Yeah, it's just neutral. Yeah, it's just oxygen in its elemental form, just hanging out. It's in a gaseous state, right? Which is just how we find it in nature. It's a 0 charge. Yeah. Okay, what about on the right here? Now we've got, this ionic compound. Ionic compound. How did I know it was ionic? Yeah, it's a metal and a non-metal. Specifically, it's a transition metal. So we need to be aware that it can make variable charges. It can have different charges when it forms an ion. But oxygen always forms what type of ion? Yeah, a 2 minus charge. Yeah, always. Okay. What about copper? If oxygen has a 2 minus charge here, what does the charge on copper have to be? Yeah, it has to be 2 plus, right? That's why they bonded together. They want to be neutral. Okay, so now what you're going to do is you're going to compare each species before and after your reaction. So before your reaction, look at our copper, right? And then after reaction, we're going to look at our copper. Okay, so let's go ahead. I like to do it this way. And I like draw a little bracket. So our copper before our reaction had a 0 oxidation number or 0 charge. And now it has a 2 plus charge. So was it oxidized or reduced? Yeah, it's oxidized. It's going from a 0 charge to a positive charge. So it must have lost electrons. It must have lost some of those negative charges. Kind of weird, right? All right, what about oxygen? Let's look at oxygen now. My oxygen went from a 0 charge, no charge, to a 2 minus charge. Let's actually move this oxidation over here just so we know it's with copper. Okay, so my oxygen went from 0 to 2 minus. So was it oxidized or reduced? Yeah, reduced. It was reduced. It was reduced because we went from a 0 charge, no charge, to a negative charge. We got more negative. We reduced our charge. Okay, so oxygen was reduced. Notice that we always have something that's oxidized and something that's reduced. So you're not ever going to have only oxidation happening or only reduction happening, because we always have, if one thing loses electrons, another thing has to gain those electrons. Okay? All right. So, go ahead and try this learning check. I'm not going to go through it with you, but go ahead and try the learning check, check your answers, and then if you have any questions, do let me know.